Okay, so today we will start part 5 polynomials. So we were doing exercise 1.3. Now we will take question number 2, find the remainder when it is divided by 5. This remainder theorem we have seen when x minus a equal to 0, find the value of x, substitute to get the remainder. That same question that we did before also. So here in question number 2, so given polynomial is bx which is equal to x cube minus ax square plus 6x minus a, and it is divided by gx, another polynomial by which it is divided x minus a. Okay. So as per the remainder theorem, we will find the value of x by equating the divisor to 0. So x minus a is equal to 0, which gives us x is equal to a. This you have to put to get the remainder, put in PS. So we get Tx is equal to a. We have to put in instead of x a. So Ta will be the remainder. Ta is equal to x cube. X is replaced by a cube minus a into x square means a square plus 6 into x means a minus a. Okay. So it will become a cube minus a cube plus 6a minus a. So a cube minus a cube will cancel. A cube plus a cube minus a cube cancel. 6a minus is 5a. Okay. So therefore the required remainder is 5a. Similarly, check whether it is factor. Actually, this is a remainder theorem we have done, and the factor theorem we have to do. So this have given this for factor theorem. If the remainder is 0, then it is a factor. So it should be done after the factor theorem. So what is the factor theorem? Then we will do this question number 3. Okay. So now we have to do factor theorem. Then this question number 3 will take, that is based on the factor theorem. So write down factor theorem. Factor theorem, if Px is a polynomial of degree n, the statement is, I'll explain you, just write down the statement. If Px is a polynomial, same thing that we have seen in remainder theorem, first point, Px is a polynomial of degree n greater than equal to 1. Means no constant polynomial should be taken, and alpha is any real number alpha is any real number, then there are two things. It gives the two statements. Number one, x minus a is a factor of px if p alpha is equal to 0. X minus alpha is a factor, is one of the factor, is a factor of this polynomial, given polynomial px. It is a factor of px if you substitute alpha in the polynomial and you get 0. If the remainder is 0, then it is a factor. That is, we can say if the remainder is 0, in other words, that is, we can say if the remainder is 0, if the remainder, in other words, we can say if the remainder, we are finding remainder for putting the value in remainder theorem. So we will do the same way. We will find the remainder. If the remainder becomes 0, then it is a factor. Then x minus alpha is a factor of, this is the first statement, is a factor of px. Okay. So same procedure, we will substitute the value equal to 0, x minus alpha equal to 0, px will be given, px will be given, qx, gx will be given. We are dividing px by gx and gx equal to 0. Okay. To solve, we get the value of x. Suppose x minus alpha, so x is equal to alpha, and this value substitute in this one, we get p alpha. And p alpha is what? This is the remainder. And if the remainder is, this is what? Remainder. So that we are doing in the previous question also. Same thing we will do. Just we have to check whether the remainder is 0 or not. If the remainder is 0, then it is a factor. If the remainder is not 0, then it is not a factor. Okay. Got it? So same procedure, just we have to check whether it is 0 or not. And the vice versa, converse statement of this one. Here, if remainder is 0, then it is a factor. If it is a factor, then remainder will be 0. Okay. So remainder will be 0. P alpha is equal to 0. P alpha is equal to 0 means remainder is 0 if x minus alpha is a factor of px. Is a factor of px. Okay, got it? That is, we can say if x minus, if x minus alpha is a factor, then the remainder will be 0. We can say in our easy language, if x minus, if it is given in the question that x minus alpha is a factor, of px, then we can equate it to 0. Then remainder will be 0. Then remainder, are you getting my point? Remainder p alpha is equal to 0. So whether, if in the question, if it is given that it is a factor, then we can equate the remainder to 0. If remainder is given 0, then sorry, if x minus 1 is a, if remainder is given 0, then it will be a factor. If it is given that it is a factor, then remainder will be 0. Okay. So only the way of way of doing is same, just we have to check whether it is a factor or not. So I will take one example, that check whether, examine whether x plus 2 linear factor, linear, it should be a linear, x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. Okay, we have to check whether it is a factor of this or not. So in order to check the factor, we will find the remainder. If the remainder is 0, then it is a factor. That's it. So if the remainder is 0, then it is a factor. So the procedure is same. Procedure of using remainder theorem, solving procedure for remainder theorem and factor theorem, same. So what we will do here, also we have given, you can write in the starting what is px here. Here you can say that here px is equal to divided here px is equal to x cube plus 3x square plus 5x plus 6, and gx is equal to x plus 2. Now we equate x plus 2 to 0, get the value of x. Okay, same procedure. In remainder theorem also, p equating this to 0, find the value of a and substituting. The same procedure we are doing here also. Okay, equating this and now find or put in px. So p minus 2 will be equal to x cube, means minus 2 cube plus 3x square, so plus 3, then x square, that means minus 2 square plus 5 plus 5x, x is replaced by minus 2 plus 6. So minus, if the power is odd, I told you answer will be negative. 2 to the 4 to the 8. When it is positive, 2 to the 4 and 4 3 is 12. When power is even, the answer will be positive. Here minus plus minus, 5 to the 10 plus 6. So 12 plus 6, 18, minus 8 minus 10, minus 18, minus 18 and plus 18 cancelled, both cancelled, we get 0. So as the remainder is 0, by factor theorem, therefore by factor theorem we can say that by factor theorem. When we are saying about the factor, then we say that factor theorem. When we are finding remainder, we will say by remainder theorem, this remainder is 0. By factor theorem, as the remainder is 0, factor theorem x plus 2 is a factor of, is a factor of x cube plus 3x square plus 5x plus 6. Okay, so like this we will use factor theorem. So that's why I have not taken this question now. We can take this question. Check whether 7 plus x is a factor of 3x cube plus 7x. 2.3. Now this question number exercise same 2.3. Question number 3. Check. This is based on the factor theorem. Check whether 7 plus 3x is a factor of 3x cube plus 7x. Okay. So here again we have here px is equal to 3x cube plus 7x, and gx divisor is 7 plus 3x. Okay. And now equate to 0. 7 plus 3x, gx is equal to 0, which implies that 3x is equal to minus 7, which implies that x is equal to minus 7 by 3. But you don't write in the same line. I have given you, this is very important. Because of this, some students are doing mistake. Do not write two steps. These are not the two steps. These are the two things. When you are solving, next step should be written below the previous step. Do not write in the same line. Always. Remember always. Okay. But here, because of less space, I am writing, but you should not write in the same line. So now this you have to put in dx. So we get the remainder. If the remainder is 0, then it is a factor. If not 0, it is not a factor. So we'll find p minus 7 by 3. Minus 7 by 3, that means 3 into x. Value of x is minus 7 by 3 cube plus 7 into minus 7 by 3. Okay. So 3 into 7 multiply 3 times, we get 343. So this will become, again you should write here step, but I am writing here 3 into negative, because the power is odd. So answer will be negative 343 upon 3 is a 9, 3 is a 27. Then again minus plus minus 7 7 is a 49 upon 3. So 3 9s are 27. 3 1s are 3, and 3 9s are 27. So we get 343 divided by 9. It is not divisible by 9. Okay. So minus 343 by 9 minus 49 by 3. So LCM will be 9. So minus 343 minus 49 will multiply with 3. So 49 3 is a 147. 147. 147 is added with 343 because they have same sign. So 490. So minus 490 upon 9. So which is not equal to 0. Okay. So therefore, we can say therefore 7 plus 3x by factor theorem, by factor theorem. Seven plus 3x not is not a factor of the x cube plus 7x. Okay, so this is the use of factor theorem. So whether it is a factor, the first question number 1, here px is the first question, px is equal to x cube plus x square plus x plus 1, and gx is equal to x plus 1. Gx is same for all the questions. Okay, so equate to 0. Now x plus 1 is equal to 0, which gives x is equal to minus 1. Put in the given polynomial px to get the remainder. So p minus 1, so x cube means minus 1 cube, x cube, then plus x square plus minus 1 square, then plus minus 1 plus 1. Minus 1 cube is minus 1, minus 1 square is plus 1, plus minus, minus 1 plus 1. All cancelled, we get 0. So by factor theorem, therefore by factor theorem, by factor theorem, x plus 1 is a factor of this given polynomial x cube plus x square plus x plus 1. Okay. Second question also same. Third is also same. Only fourth we could take actually, because fourth is having root. Okay. So I will take question number 4. Then px is given in this question. Px is equal to x cube minus x square minus 2 plus root 2 x plus root 2. So these two questions are homework. This question number 1, this is homework, and this is also homework. And gx is same in all the questions. Gx is equal to x plus 1. So equating x plus 1 to 0, x plus 1 is equal to 0. Therefore, x is equal to minus 1. This you have to substitute in px. So we get p minus 1 equals to minus 1 cube. X cube minus x square minus 1 square minus 2 plus root 2 as it is 2 plus root 2, then x is equal to minus 1 plus root 2. Okay, are you getting? Then minus 1 cube is minus 1 and this will become plus 1. This will become plus 1, but because of this minus, this will become minus 1. Okay, got it? And then multiply this minus 1 and this minus will become plus. Minus into minus plus and all will become plus. So plus 2 plus root 2 plus root 2. But minus 1 minus 2 plus 2 plus root 2 plus root 2. These 2 will cancel. Root 2 plus root 2, 2 root 2, which is not equal to 0. It is not equal to 0. Therefore, by vector theorem, x plus 1 is not a factor of, is not a factor of x cube minus x square minus 2 plus root 2 x plus root 2. Okay, got it?